Hello and welcome, and thank you so much for choosing to learn with me today. So in today's video, we're just gonna have a quick recap or revision on what we have done on the two previous grades, which is grade 10 and 11, and but we're gonna look a bit much more into quadratic number patterns, right? Remember, in grade 10 and 11 we learned about two types of number patterns, right? We learned about a linear pattern, right? And we said a linear pattern has a constant or common first difference. Remember that. And we learned about another type of number pattern, and we said it was a quadratic pattern, right? We said a quadratic has a constant, right? A constant or common. Now, not a first, but a second. A constant or common first difference. Remember that. So now let's look deeper into the quadratic pattern and try to explain what it really means, what really means for it to have a constant second difference, right? So let's look at an example. Let's use an example to do that. All right. Before we look at an example, right? Before we look at an example, let's first remind ourselves. Okay. Let's first remind ourselves that it has a general term. We said a quadratic number pattern has a general term. Tn is equal to an squared plus bn plus c. All right. It's very, very much important for you to understand what each of these variables in this equation mean. All right. Firstly, I will start with the a, b, and c. Right. So a, b, and your c are constants. These are just constants. They do not change. Once you find them, the values remain the same. They do not change throughout the equation, right? Your n may change, your tn may change, but the a, b, and c do not change. They are constant. Just like in any equation in functions, if you remember functions in grade 11 and grade 10, in functions you had to find your constants a and b, right, in quadratic functions. All right. Now let's look at your n. What exactly is n? So this n right here, your n is the position. The position is the position of a number or a term. Position of a term, right? I'll just, okay, let me just write it in full. Okay, it's the position of a term or a number in a pattern, right? In a number pattern. So it's just the position. All right. What do I mean by the position? Now, let's take an example. Let's take this example 2, 3, 6, and 11, etc., because it doesn't end there. All right. So if you look at 2 right there, 2 is in position 1 in this sequence or in this pattern, and 3 right here is in position 2. And 6 is in position 3. And 11 is in position 4. Right? You get that? So this N right here stands for this position. This term is in position, this term right here, 3, is in position 2 in this sequence. Right? I hope you get that. So now that we understand what N is and what A, B, and C are, let's see what Tn is. Tn right here is the value of a term in a certain position, or the nth position, right? Hence Tn, the term in position n, right? So this n right here stands for a position number. This 2 is a position number right there, right? Position 2, position n, exactly. So the value of the term in the, let me write it in full and say the value of the term let me get rid of this. Delete, thank you. The value of the term in nth position. You get it? So we have position 2. That's the nth position. We have 3 over there. That's the value. That's your Tn. 3 is the value in position 2. The value of the term in position 2. Exactly what this Tn means. The value of a term in the nth position. Alright. Now, we talked about this general term right here. Right? So, when we look at this general term, right, the question may arise as determine the nth term, right? The nth term. The nth term, they are referring to the general term. So you should understand, whenever they say the nth term, they are referring to this equation here. Okay? Always remember that. Please do not forget. All right. So we have the number pattern 2, 3, 6, and 11. Right? So we want to find the nth term or the general term of this number pattern. Right? So remember we said Tn is equal to an squared plus bn plus c. Alright, so when finding the nth term of a quadratic sequence or quadratic number pattern, we first need to find the constants. The constants are a, b, and c. Right, how do we find those? So, remember we said it has the constant second difference. What does that really mean? Considering this pattern, we can take the difference between the consecutive terms, right? And let's do that. 3 minus 2, those are consecutive to each other, right? We get a 1. 6 minus 3, we get a 3. 6 and 3 are consecutive to each other, right? And 11 minus 6, we get a 5. Those are consecutive to each other, right? So this right here is the first difference. This is the first difference. But we talked about the second difference. So the second difference arises from these. The second difference arises from here, right? So if we take the difference between these, then we get the second difference. Let's do that. 3 minus 1 is equal to 2. 5 minus 3 is equal to 2. Indeed, the second difference. This is the second difference. The second difference is what? Is constant. Constant means it doesn't change. Common means they are the same. You understand? They are the same. This is 2, this is 2. They are the same. They do not change. Right? They did not change. They are the same. They are constant. So now, this is how you find your A's, B's, and C. Right? So you only look at these first terms. These first terms. These are the only numbers that you consider. Right? So this first term, these two in the quadratic sequence, this first term right here is equated to A plus B plus C. So that number right there is equal to A plus B plus C. And this one here is equated to 3A plus B. So 3A plus B is equal to that number, is equal to this number and only this number, right? The first number only. And then you come to here to 2. You say 2A is equated to this number. But then this line right here is always constant, right? So it's equal to the second constant, is equal to the second difference, or the constant second difference. All right. So now this is how you solve it, right? You solve it going from bottom to top. All right, because we only have one unknown here at the bottom, right? So you say 2A is equal to 2. All right, 2A is equal to 2, and then you solve for your A. Your A is equal to 1, right? How do you do that? You divide by 2 both sides. All right, you get that? Thank you. I'm glad you get that. So we go on now. We have our A. We look at this one. Since we have our A, we know what A is, the value of A is. We only have one unknown. What is that unknown? That unknown is B. So we go on to plug in our value of A. It becomes 3 times 1 plus B. Right? What is it equated to? To this first number right there, which is, in this case, is 1. All right? So we say 3 plus B is equal to 1. And then we transpose 3, it becomes negative. Then we say 1 minus 3. Then 1 minus 3 becomes negative 2. Right? So our B is equal to negative 2. You get that? Thank you. So now we have the value of A. We have the value of B. We only left with one unknown. What is that unknown? That unknown is C. And we know an equation that says A plus B plus C is equal to this first number right there, which is 2, right? So we equate that to 2, right? But we know the values of A and B. So let's plug in our values. That's 1 minus 2 plus C is equal to 2. All right. So 1 minus 2 is negative 1. Transpose the negative 1 to the other side. It becomes positive. Then you have your C is equal to 3. Right. So now we have our A, B, and C. Remember, our equation is Tn is equal to An squared plus Bn plus C. All right. So let's plug in what we know. What do we know? We have the value of A, we have the value of B, we have the value of C. So we can plug in those values because we know them. So we get our Tn is equal to 1n squared plus B. But our B is negative, so let's get rid of this B, and we have of this plus, and we have minus 2, which is the value of B, n plus our value of C, which is 3. This is our equation. So our final equation is equal to Tn is equal to n squared minus 2n plus 3. Right? Exactly. Now, this equation right here, this equation, this is the golden equation for you to find any value in this sequence, in this sequence that we were given, this sequence 2, 3, 6, and 11. We can find any value in this sequence. So let's pick 3. 6. Let's pick 6. We try, but we know 6 is in position 3. So let's try to find the value of the term. Remember, the value of the term, that's our Tn. Let's find the value of the term in position 3 and see if we do get a 6. If we do not, then we are wrong. All right. So we said we want to find T3 because our n is the position, right? So in each and every place where there is n, we plug in 3, which is the position, minus 2 times our position is 3 plus a 3. That's a constant. All right. Let's work it out. All right. 3 squared is 9 minus 2 times 3, that's a 6, plus a 3, right? Let's work it out. 9 minus 6, that's a 3, plus a 3, right? This 3 right here. All right, so 3 plus 3, that's 6. So T3 is equal to 6. Indeed, it is 6 is what we are given here, and it is in position 3. The value in position 3, the value of position 3 is 6. The value of the term in position 3 is 6. So we are correct. We find the general term, we find the general equation that we can use. All right. Thank you so much for watching, and please do come back for more videos, more exciting videos. And on the next video, we're gonna go deeper into sequences. We're actually gonna look at the linear